Good morning students. Today we'll continue with chapter solution. Yesterday we have seen Henry's law for dissolution of gas in liquid, and we have also seen the characteristic of Henry's law constant. So today we'll continue with application of Henry's law. Now Henry's law is applied in packing of cold drinks. You know that in soda water, the carbon dioxide gas is dissolved in water and the bottles are sealed under pressure. It is sealed under pressure because more of the gas molecule will dissolve in water, that is solution. As soon as we open the cold drink bottle, the gas fizzes out. Gas fizzes out because atmospheric pressure is less than the pressure under which the cold drink bottle is packed. So, after cold drink, next is in scuba diving. Now, scuba diving is done to learn under ocean the flora and fauna and how the lifestyle goes on, and also to search for pearls and all. So, scuba divers, they carry oxygen cylinder with them. Oxygen which is diluted with helium. Pure oxygen we cannot inhale. Otherwise, it harms. Okay. So, what happens when they go deep under the sea? Pressure on their body increases. Due to increased pressure, more of gas is dissolved in blood. When they come out and they come at atmospheric pressure where pressure is less of air, suddenly the dissolved gas starts coming out from the blood. Due to that, they suffer a pain which is called as bands or edema. So to avoid that condition, they carry the oxygen cylinder to maintain the pressure in blood. Similarly, mountaineers also, when they climb the mountains, up on the air or up on the mountain, the the pressure of the air is less. Due to that less pressure, less of oxygen dissolves in blood. So they may start suffering from unconsciousness or breathing problems. So to overcome these breathing problems, they also carry oxygen cylinder with them so that they can inhale more oxygen. So here we complete application of Henry's law. After that, next topic is vapor pressure of liquid. Now, mainly our solvent is liquid in most of the solutions. So now we will focus on the liquid solvent. So liquid solutions, which is binary. Binary means which contain two components. Now if I have a pure liquid in a beaker, the surface molecule of that pure liquid are having little more energy. We have studied this in 11th standard. Why they are having little more energy? Because their residual forces are not balanced. So they try to escape the surface and they start collecting over the surface of liquid. Suppose I close the beaker, then vapor is not allowed to escape in atmosphere. If the beaker is open, vapor will escape. So what happens? After some time, this place gets saturated with vapors of liquid, and that vapors of liquid starts exerting pressure back on the surface. So pressure exerted by vapors of a liquid over its surface is called as a vapor pressure of a liquid at given temperature, and it is denoted with P naught. This is vapor pressure of pure liquid. Suppose now I am adding solute to it, which is solid. When solid solute is added, some of the solute particle replaces the surface molecule. So number of surface molecule passing into the vapor phase decreases. When number of molecules passing in a vapor phase decreases, the vapor pressure of the solution also decreases, because when I add solute to solvent, it becomes a solution. So vapor pressure of solution is denoted with P1, and P1, that is vapor pressure of a solution, is always less than vapor pressure of pure liquid. So definition of vapor pressure and how the vapor pressure of solution decreases, that you have learnt in this. Next we have vapor pressure of binary solution which contains both components as volatile liquid. Now what is meaning of volatile liquid? Volatile means something which evaporates easily. That is called as volatile. When both the components are volatile liquid, I get liquid-liquid solution. Both the components are liquid and both are volatile. That is the essential condition. So both the liquid will have their pure liquid vapor pressure. When they are separate, they are not mixed. They will exert their own pressure. So one of the liquid will act as a solvent which is present in more quantity, and the other will act as a solute which is present in less quantity. So they will have their own pure liquid pressure which can be denoted as P01 and P02. P01 is component 1 which is for solvent. P02 is for component 2 which is for solute. You know the denomination. So this is the vapor pressure of pure liquid 1 and pure liquid 2. After they are mixed, they will have their partial pressure in the solution, for component 1 as P1 and for component 2 as P2. This is after they are mixed. So in solution they both will have their own partial pressure because each one of them have different volatility. One liquid may be more volatile as compared to another. So in case of both components are volatile liquids, the vapor pressure of a liquid is governed by Raoult's law. According to Raoult's law, for a binary solution which contain both components as volatile liquid, vapor pressure of each component is directly proportional to mole fraction of that component in solution. Once again, for a binary solution which contains both volatile liquids, vapor pressure of each component is directly proportional to mole fraction of that component in a solution at given temperature. So mathematically, when I want to represent the law, for component 1, vapor pressure of component 1, partial pressure of component 1 will be proportional to chi1. To remove the proportionality sign, I have to use constant, and that constant is vapor pressure of pure component 1. So I can write it as P1 is equal to P01 chi1, and vapor pressure of component 2 is proportional to chi2. So I can write it as P2 is equal to P02 chi2. This is my equation 1. This is my equation 2. Now, what will be total vapor pressure in the solution? If you remember, we have studied Dalton's law in 11th standard. According to Dalton's law, P total is equal to partial pressure of component 1 and partial pressure of component 2. So, if I substitute the value of P1 and P2 from here in this equation, I get P total is equal to P01 chi1 plus P02 chi2. Now I will replace this chi1 as 1 minus chi2 because it is binary liquid. So chi1 plus chi2 is equal to 1. So as chi1 plus chi2 is equal to 1, I can write P total is equal to P01 into 1 minus chi2. For chi1 I am substituting. So 1 minus chi2 plus P02 chi2. Let me open the bracket. After opening the bracket, I will get P total is equal to P01 minus P01 chi 2 plus P02 chi 2. Now I can take positive chi 2 as common. So it will become P01 plus positive chi 2 I am taking outside. Inside the bracket, I will write positive term first because here there is a negative sign. So it will become P02 minus P01. So P total is equal to P01 plus chi 2 into P02 minus P01. So this is vapor pressure of pure liquids 1 and 2. Now according to Raoult's law, that is P2 is equal to P02 chi 2. I can generalize few things from this, that vapor pressure of solution, that is P total, this is vapor pressure of solution, can be equated to mole fraction of any one component. Either it can be equated to chi 2 or it can be equated to chi 1. Vapor pressure of the solution is directly proportional to chi 2, because in final expression I have got chi 2, that is mole fraction of solute, and it varies linearly with change in chi 1. It also varies linearly with change in chi 1. So these are the three characteristics of vapor pressure of a liquid, and thus we have completed one form of Raoult's law, that is binary solution in which both the components are volatile liquid.